Hi, we have studied what is breadth-first search and we have designed a high-level algorithm. Now we have also seen with an example how the algorithm actually works. Now we are going to implement it in Python. If you want to implement it in Python, in order to do all these activities, we need certain data structures. We are going to see those data structures. So the first data structure is a queue. We need a queue in which the nodes are kept and then one by one we pop and then do the exploration. So there is a queue. Queue is a first in first out data structure. In Python, we are going to implement it using a Python list. So queue is a Python list. Then we have to keep track of explored nodes. What are all the explored nodes? So explored is a set of nodes which are already explored. In Python, there is a data structure called set. You can either use a set, you can define a set called explored. Whenever you explore a node, you can add it to that. That is one way of doing. Otherwise, you can consider a Boolean list explored because we are having the nodes numbered from 0, 1, 2, 3 and n minus 1. So if you create a Boolean list called explored, when it is empty, all of them will be false. The initial node will be added by saying that node equal to true. For example, if 0 is the initial node, initially explored of 0 will be true because it is already explored. Something like that. So there are two ways of doing it. One is in Python there is a data structure called set and you can create a set called explored. The other is you can have a Boolean list called explored. For each vertex, whether you can decide true or false. If it is true, that node is already there. Otherwise, no. Then in the BFS tree, normally a rooted tree is represented by the parent relation. For each node, there is only one parent. That is the tree. If you look at the tree, every node has only one parent. If that is defined, the BFS tree is defined. So we will create a parent. Similarly, we are partitioning the nodes into various levels. Node at level 1, 0, level 0, node at level 1, node at level 2, and so on. So there are 4 important data structures we maintain: queue, explode, parent, and level. So let us now develop a detailed algorithm so that this can be converted into a Python program easily. So what is the input? A graph. The graph represented by the adjacency matrix. So there is an adjacency matrix. If the nodes are 0, 1, 2, 3 up to n minus 1, then there is a n by n matrix where Aij equal to 1 if I and j are adjacent. So it is represented by the adjacency matrix. That is the input. Number 2, a search criteria to search every vertex. When we search each vertex, exploring, it may be a success or failure. For each node, either the solution is available or not. So in the previous example, we assumed that you know where the solution is available. So we searched every node and finally said no. So here, the input must say, where is the solution? Is it in 0, 1, 2, 3 or in minus 1? So if the solution is not available anywhere, all of them must be false. If it is available in a particular node called 5, for example, then that should be success. So that is one. Then what is the initial node? Assume that we start from 0. So these are the 3 input. So the problem is defined by the graph. So the graph will give you what are the nodes and what are the edges. Then there is a Boolean list which says where the solution is, and what is the starting point. So these are the three input. Now output will be, you initialize from 0 and search, and finally you get the BFS tree. So the order in which you are searching, if it is available somewhere, then success. Otherwise, you search everywhere and finally you output the BFS tree and say that I have searched everything, the medicine is not available. So this is the output. So the output is either success or failure together with the parent list. The parent list will define the BFS tree completely. So let us first initialize. What is the first step? We will have to initialize. For example, Q of 0 is init. In the Q, first you put 0, first value. Wherever we start, that is in the Q. Explode, it's an empty set. We have not explored anything. Then parent of, now initially we will say parent of I equal to I. Now level is also, all of them are 0. Solution, for this problem we will assume that the solution is not available anywhere. Now this is important. So we will continue the loop. What is step 2? We will continue the loop until the queue becomes empty. What are we going to do? You pop one entry, call it I. That is, I is pop queue of 0. So in the queue, the 0th element will be pulled out. That is pop. Now verify whether the medicine is available there in I. So if solution of I equal to true, then we can return. That's all. Then it is ready. Then end of algorithm. Otherwise, go to next step. What is to be done in the next step? Assign explode of I equal to true, because I is now explode. So you put it into the set called the explode. Now we have to do one thing. For I, we have to find out all the neighbors. Among the neighbors, if it satisfies the 2 conditions, you will have to add it to the queue. What are those 2 conditions? 1, it is neither explode nor already in the queue. So if explode of I equal to false, it means it is not explode, and J is not already in the queue. If these 2 conditions are satisfied, it should not have been explode, it should not have already been in the queue. So if those 2 conditions are satisfied, add J to the queue, append it to the queue, and in such a case, parent of J is I, because that is the neighbor, So this is the parent, I is the parent, and J is the child. So if this is continued again and again, repeat, the loop will be repeated. So what is the loop repeated? Let us look at it again. Pop the entry, look at it. So pop the queue. It means there is a queue and you pop the first entry. So I becomes pop of queue of 0. Now verify if the solution is true, if the medicine is available in I. If it is available, then we are done. We have solved the problem. There is a success. Otherwise, what should be done? First, mark I as explode. In the explode set, put I inside. Then look at all the neighbors of I. Look at it. Each neighbor node J. Verify 2 things. 1, it should not have been explode. Number 2, it should not be in the queue. If those 2 conditions are satisfied, add it to the queue. So then you repeat. Then you check whether the queue is not empty. Until empty, we will have to repeat it. Pop, explode, check whether the solution is available. If not, you add it to the explode set. Then you find out all the neighbors. Among all the neighbors, if there is any neighbor which is satisfying 2 conditions, not explode, not already in the queue. If they satisfy, put it in the queue. So if you repeat it again and again, at one point in time, the queue becomes empty and then you go to the next step. So we reach the step, this indicates that the queue is empty. No more node to be explored. So we have reached the end. So that is the detailed algorithm of breadth first search. Thank you.